Back to my channel. Today I'm going to discuss interesting Xor with you. That is problem number. That is problem number 7 of the May long challenge course. So without wasting time, let's start discussing the problem. So I'm going to read the problem statement and I'm going to briefly explain you what's the problem about and how to approach the code. Before starting, I would like to request you that if you haven't subscribed my channel, then please subscribe it. And if you like my video after watching it, then please give it a thumbs up. Okay, let's start now. Janka finds one in everyday simple things. One find A got interested in a very trivial sequence. Given a natural number k, he considered the sequence ai equals to k plus I square. So the terms are k plus 1, k plus 4, k plus 9, and so on. So let me go into the whiteboard. Let me clear this one. Okay, so it has been given that a sequence has been given to you, and the sequence is equation of the sequence is like ai equals to k plus I square, and k is a natural number which will be given to you, okay, in the input. So I write the sequence this way. Let me write the sequence for you. So if I write the sequence, what's the sequence? Sequences, that is ai, that is k plus I square, okay, k plus I square and 2i, that's right. Okay, this is the sequence. So this is the sequence. Now it has been told you. Now the things more now to make things more interesting, he considered GCD of consecutive terms. Okay, so now to make more interesting this problem, he considered a thing like he wants to find the GCD of two consecutive sequence. Okay, two consecutive numbers. Two consecutive numbers. Two consecutive terms in the sequence. Okay, then take the sum of the 2k values. Okay, so he wants it, like you will be given, you will be in the input, it will be given t, the test case, number of test case, and k. What's the k? K is the value here which we will use in the equation. Okay, so t will be given to you, and what he wants, using this equation, he will form a sequence, and from that sequence, he wants the sum of the GCD of two consecutive terms. Okay, so if I consider like, let me take the value of k equals to 1. So what will be the sequence? Let me write the sequence. Like k value is 1, so 1 plus 1 is 2. Then what's the sequence? K 1 plus 4, that is 5. Then k, that is 1 plus 9, 10. So in this way the sequence goes on. Okay, then 1 plus 6, that is 17. So this is the sequence. This is the first four term of the sequence. So from the sequence, what he has told further, that you have to find, what you have to find, you have to find the GCD of two consecutive terms like this one, and you have to store it in sum. You have to find all the you have to find the GCD of all the consecutive term and store in the sum value and print it that way. Okay, this as simple it is. You just have to find this sequence. Now, how to do this problem? Denote as, okay, one more thing, the sum you get, the sum you will find after solving this problem, you have to return it by doing the mod value with 10 to the power 9 plus 7. Okay. Now, if you see the constraint over here, if you see the constraint over here, t equals to 10 to the power 6. T is 10 to the power 6 and k equals to k is what? K is also 10 to the power 6. So now how to do it? If we calculate the time complexity in which we have to that is do this problem, so and let us see the time given, in which time limit given, that is 1.5 seconds. So the time limit is given what? Time limit is time limit is 1.5 seconds. It means what? It means that you have to perform this in 10 to the power 12 that is 10 to the power 12 operation per second. You can perform 10 to the power 12 operation per 1.5 seconds. You have to do in this way. Okay, so since we know that 10 to the power 8 operation can be performed in 1 second, so in the problem it has been provided the time limit is 1.5 seconds. So if we use the unitary method, we can that is evaluate the corresponding operation, okay, of 1.5 seconds. So it comes out to be 10 to the power 12 operation per 1.5 seconds. So if we calculate this like O of what? O of t into k, then what? It is exactly 10 to the power 12 per 12 operation per second. Okay, so we need to do what? We have to do it in O of n time. Okay, we have to do it in O of n time. So let us see how can we approach this problem in O of n time. Okay, so if we carefully observe the problem statement over here, like this is the sequence given over here, and if we write the sequence, like what we can write the sequence. Let me write the sequence for you. Like this is the sequence 2, 5, and what else? 2, 5, 10, 17, then 26. What else? This is the sequence corresponding to the value of that is value of k is 1. Okay, so what else? 36 plus 1, that is 37, and 49 plus 1, that is 50. 50 plus 1, 64 plus 1, that is 65. 65 plus 1, after that 81 plus 1, that is 82. Then what? 100 plus 1, that is 101. So this is the sequence corresponding to the value of k equals to 1. Okay, so now let's see if we can observe anything over here, like 2, 5, 10, 17, 26, 37, 50, 65, 82, 101. Okay, so I think this video is getting longer, so in order to keep this video short, I'm making this as a part 1, and part 2 will be uploaded in my next video. Okay, so till then keep coding, and thank you.